Okay, so in this video, we're going to discuss the law of sines. The law of sines is used to solve a triangle when you know three sides of the triangle or when you know two sides and an included angle. Recall that the included angle means that it is an angle in between two known side measures. Now, the law of sines has three different formulas. And based on the information that we know, we need to choose the correct formula. Something we should pay attention to is the angle inside of cosine matches up with the opposite side from that angle. So the a squared is isolated on the other side of the equal sign. Or if we're using cosine of b, then it is the b squared that is isolated on the other side of the equal sign. Or if we are using angle c, it is the c squared, the side opposite angle c that is isolated on the other side of the equal sign. So with all that said, we have to choose the appropriate formula, and we will apply law of cosines when we have an SSS pattern or an SAS pattern. And as we did with law of sines, we are going to use the standard naming of a triangle. The three capital letters are A, B, and C for the angles, and then the sides opposite will be the corresponding letter in lowercase form. So if we look at this first example, it asks us to determine the unknown measures of the triangle ABC. That means find angle C, angle A, and side B. So for us to do this, we have to determine is law of cosines or is law of sines the best formula to use here. We see that we have a side angle side pattern that tells us to use the law of cosines. Now, since we know angle B and we need to solve for side B, we should go back and say, let's use that form of the law of cosines formula. The b squared equals a squared plus c squared minus 2ac times cosine of b. And let's plug our numbers into here. So we see that a is equal to 6, c is equal to 10. Let's plug those in. And angle B is 72 degrees. So we can evaluate all of this with our calculator. And we see that B squared is equal to 98.92. If we take the square root of both sides, we can find the value of B. So B is approximately 9.95. And we'll plug that into our triangle here. And now to solve for the remaining parts, we can use the law of sines. So this is the typical pattern for solving these problems. After we've applied law of cosines once, the rest of the work can be done with law of sines. So sine of angle A over 6 is equal to sine of angle B, but angle B we know as 72 degrees, over 9.95 is equal to sine of angle C over 10. And we just need to take two of these ratios together. And now we can solve for sine of A equals 6 times sine of 72 degrees over 9.95. We need to use sine inverse to get the measure of angle A. So back to our calculator. Second sine gives us the sine inverse. 6 times sine of 72, close the parentheses, divided by 9.95, close the parentheses again, and we get that angle A is about 35 degrees. Once we get 35 degrees for angle A, then we can find angle C by subtracting from 180. So subtract our 72 degrees, subtract our 35 degrees. And that tells us that angle C is 73 degrees. So we've solved for all the unknown measures of triangle ABC. So here's another example, and we'll see that this time we have an SSS pattern. So we can use any of the three formulas when we know all three sides. So we'll use a squared equals b squared plus c squared minus 2bc sine of a. So we see that a is equal to 9, b is equal to 12, and c is equal to 7. And we'll simplify the expressions in here. So our goal here is to solve for angle A. We have to be careful because we see that 168 is being multiplied by sine of A. We have to keep these two together, make sure we don't cause any PEMDAS errors as we're solving. And we see that we can combine 144 with 49. So we have 81 equals 193 minus 168 sine of A. Let's subtract 193 from both sides. That gives us negative 112 equals negative 168 times sine of A. Let's divide both sides by negative 168. So negative 112 divided by negative 168 gives us 0.6 repeated. Now to solve for angle A, we need to take sine inverse of both sides. And we get that angle A is about 41.8 degrees. Once we have that measure for angle A, we can use law of sines to solve for the rest of the parts. So let's solve for angle B now with law of sines. We're taking the inverse sine of both sides to get angle B. Let's enter that into our calculator. And we have that angle B is about 62.7 degrees. And now we can subtract these angles from 180 to get the third angle. And angle C is 75.5. So we solve for all the parts of triangle ABC given an SSS pattern. Here's an application problem that will involve law of cosines and law of sines. It states that a crane is being created by 4 steel members in bold. So these are the bold segments of the image for the crane. And a cable shown in the diagram below. Here is our cable. It is known that AC is 10 feet, that AB is 8 feet, that the measure of angle A is 40 degrees, and that the measure of angle CBD is 65 degrees, and that the measure of angle D is 45 degrees. So we've got all of this marked in the image. It says determine the length of the support member BC to the nearest hundredth of a foot. So our goal is to calculate BC. I'll put an X there. And we see that we have a side angle side relationship here. And I'm going to simplify this and just take triangle ABC, so I'm not looking at too many different segments. We're trying to solve for this side over here, where I put an X there, but let's put the letter A, since that is opposite angle A. So we're going to solve for A. We know that side AC is 10 and side AB is 8, and that the measure of angle A is 40. Let's plug this into our law of cosines formula. We know angle A, so we'll use A squared equals B squared plus C squared minus 2BC times cosine of angle A. So B squared is going to be 10 squared. C squared will be 8 squared minus 2 times 10 times 8 times cosine of 40. So 10 squared is 100, 8 squared is 64. We'll add those, then subtract 2 times 10 times 8 is minus 160 times cosine of 40. And this is our A squared, so it's 41.4. And if we take the square root, it gives us that A is about 6.44. So it says determine the length of the support member BC. BC from B to C is the value of A to the nearest hundredth foot. So BC is about 6.44. Next, it says determine the length of the cable CD to the nearest hundredth foot. And we want to take this triangle and simplify it. So now we have triangle C to D to B. We just solved for BC, saying it was 6.44. And we know that angle B is 65 and angle D is 45. This is an angle-side relationship. That means use law of sines. So I'm going to clone this page and clear the ink. And let's continue solving this triangle that we drew out here. Our goal is to solve for side B because it's asking for CD. From C to D right here is side B, using the naming convention for our triangles with capital and lowercase letters. So we can say sine of B over B equals sine of C over C equals sine of D over D. And we understand that this is our lowercase letter d, and down here is our lowercase letter c. So we know that lowercase d is 6.44, and its corresponding angle is 45 degrees. And we would like to solve for b, and its corresponding angle is 65 degrees. And this is the proportion that will let us solve the problem. Let's cross multiply. And we get b times sine of 45 degrees equals 6.44 times sine of 65 degrees. And now we'd like to get b by itself, so we'll divide both sides by sine of 45. So that gives us b is equal to 6.44 times sine of 65 degrees over sine of 45 degrees. And let's plug that into our calculator. And that gives us b is 8.25. So determine the length of cable CD to the nearest hundredth of a foot. And there's your answer to part B. So this was a two-part problem. The first triangle used law of cosines. The second triangle used law of sines. And in this last frame, we're just looking at identifying which method do we use based on the information given. And just as a recap, we see that law of sines is used if we have an ASA and AAS or an SSA relationship, and law of cosines is used if we have an SAS or an SSS relationship. So if we look at number one, we see there is an angle, and a side. That is an AAS relationship. We would use law of sines here. In number two, we're given a side relationship. We would use law of cosines. Number three, we have a side relationship. That is law of cosines again. And in example 4, we have an angle followed by a side followed by an angle. That is a law of sines relationship. So this concludes our lecture. Watch the video again, take notes, and then try the practice problems I posted. Send me questions in email if you have any.